Back to today's video. In today's video, we'll be talking about the slope of a tangent. So just a review of lines. So if we remember, the slope of the line is represented by the equation m is equal to delta y over delta x, which means, again, the change in y over the change in x. And so we can write that as y2 minus y1 over x2 minus x1. So if we look here, we see again that we take the point indicating x and y, and we take our second point of x and y, and then we can find our slope of the line. If we look at a review of secant lines, if the point P, which is represented as a and f of a, and the point Q, which is represented as x plus h, and the function of a plus h around the function f of x, then the slope of the secant line between P and Q is given by this equation here. So if we draw a table of values for x and y, if our first point is A, if we look at the graph on the right, our point P here is A, will be x1, and our y value will be f of A, which will be y1. And for our second x value, we see that it's going to be x plus h, and our y value will be the function of a plus h. And it's a plus h because it's moving positively to the right on the x-axis. And so we see that we have a plus h, and then it is the function of a plus h. And so here we can write that a plus h would be x2, and the function of a plus h will be y2. And so if we understood that, again, slope is equal to y2 minus y1 over x2 minus x1, we can rewrite it as m is equal to the function of a plus h minus function of a over a plus h minus a. We see here there's positive a and the negative a can cancel out. So here we can rewrite the equation as m is equal to f of a plus h minus f of a over h. Okay, so let's look at the slope of a tangent line. So consider a point Q on the curve. So consider a point Q on the curve. As Q gets closer and closer to P, the slope of the secant PQ becomes progressively better estimate of the slope of the tangent at P. So in other words, the slope of the tangent is said to be the limit of the slope of the secant as Q approaches P along the curve, or the horizontal distance between Q and P approaches 0. And this can be expressed algebraically as m is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. And this is what we see as the slope of the tangent. So if we look at this graph over here, we have point. And so here at the point here, at point P, we see that h is 0. And here we can see that if there's another point here, that's going to be a plus h and f of a plus h. And here, what we're doing is, again, we're trying to reduce it so that h, again, gets closest to 0. So as we move it over and over, it gets closer and closer to 0. So here, what we're trying to do is we're going to try to reduce h to be 0. Okay, so the equation again for the slope of the tangent is the limit as x approaches 0, f of a plus h minus f of a over h. And so if we notice here that h is in the denominator and h is equal to 0 represents a restriction. So since h is equal to 0 represents a restriction, our goal will be to simplify limits and eliminate h from the denominator. Okay, so let's look at this example. So it says, find the slope of the tangent line to the graph of f of x is equal to x squared minus 3x at the point 1 and negative 2. And so our 1 and negative 2 is going to be our a value and our f of a value. So here, if we write our equation that we just looked at, m is equal to the limit as h approaches 0 of f of a plus h minus f of a over a plus h minus a. And again, here we know that the a's will cancel out. So we'll be left with the limit as h approaches 0. And we can start subbing the values we have in. And so we know that a is going to be 1. So we have f of 1 plus h minus f of 1 over h. And so here we see that if we have the function of 1 plus h, we can rewrite it as the limit as x approaches 0, 1 plus h. So we're subbing that into our x value. So we have 1 plus h squared minus 3, 1 plus h minus negative 2. And we get that negative 2 from f of a. And all of that is over h. So here, if we expand, we get the limit as h approaches 0, 1 plus 2h plus h squared minus 3 minus 3h plus 2 all over h. So here we can cancel out a few things. So we can cancel out 1 plus 2 and negative 3. So positive 3 and negative 3, those will cancel out. And here, we'll be left with h squared So collecting our like terms, we'll be left with h squared minus h over h. Here we can factor out our h value from the numerator. So we'll have to limit as h approaches 0, h bracket h minus 1 over h. The h's will cancel out. And so here we'll be left with the limit as h approaches 0 of h minus 1. So here we sub in 0, we'll get an answer of -1. And so what does that mean? It means that the slope of the tangent line at this particular point is 1 and 2 is -1. Okay, so let's look at example 3, and here we're going to find the slope of the tangent line to the curve f of x is equal to 2 square root x minus 1 at the point 5, 4. Okay, so again, here we are given the point at 5, 4. And we're given the function f of x is equal to 2 square root x minus 1. So we're going to find two things to start. Find the function at x is equal to 5. And so if we sub that in, we have 2 square root 5 minus 1, or 2 square root 4, which simplifies. So 2 times 2 simplifies to 4. So f of 5 is equal to 4. Here, if we find the function of 5 plus h, that's equal to 2 square root x minus 1. So here it's 5 plus h minus 1. And we'll be left with 2 square root h plus 4. So now we can write it to our equation, and we know that slope of the tangent is equal to the limit as h approaches 0, f of a plus h minus f of a, all over h. So here, if we rewrite what we found, again, we know that f of a plus h, f of a plus h is equal to 2 square root h plus 4 minus f of a, which is 4, over h. And here, what we want to do is we want to conjugate the numerator, again, using the conjugate radical. So we're going to multiply by the conjugate radical. In this situation, it's 2 square root h plus 4 plus 4. So remember, changing the sign, and 2 square root h plus 4 plus 4. Put some brackets around this as well. And so here, if we simplify, we'll get the limit as h approaches 0 of 2 square root h plus 4 minus 4 multiplied by 2 square root h plus 4 plus 4. And here, what we'll get is we'll get 4 bracket h plus 4 minus 16 over h bracket 2 square root h plus 4 plus 4. Here, if we can expand it, so we'll see here limit as h approaches 0, 4h plus 16 minus 16. See that positive negative 16 will cancel out. Then we have h bracket 2 square root h plus 4 plus 4. Here we'll just rewrite it after canceling out the plus and minus 16. The limit as h approaches 0 of 4h over h bracket 2 square root h plus 4 plus 4. Remember, our goal is to cancel out the h. Here, we can cancel that out from the numerator and denominator, and we'll be left with 4 over. And so we can calculate that by subbing in h is 0, 2 square root 0 plus 4 plus 4. And 2 square root 4, again, is equal to 4. And then 4 plus 4 must be 8. So we'll be left with 4 over 8, which we can simplify to 1 over 2. So therefore, we can write therefore statement, the slope of the tangent therefore the slope of the tangent at point 54 is 1 over 2. Okay, so let's look at this last question here. And again, it says find the equation. So again, find the equation of the tangent line. So we know that the equation of tangent line will have to find y is equal to mx plus b. If the graph of f of x is equal to 4 over x at the point where x is equal to -2. And so here, y is equal to mx plus b. We are going to need to find both m slope and b the y-intercept. So here, x is equal to 2. We need to find the corresponding y value. So here, we need to find the corresponding y value. So here we know that our f of x, or our function, is equal to 4 over x. We know that if we sub in f of -2, we will have 4 over -2, which is equal to -2. And if we sub function of a plus h, here it's -2 plus h, we'll get 4 over -2 plus h, or we can write it as h minus 2. So here, if we have the slope is equal to the limit as h approaches 0, again, if you remember our equation, it's f of a plus h. Here, in this situation, it's 4 over h minus 2 minus f of a. Here it's -2, so minus 2 all over h. So here, if we find the lowest common denominator of h minus 2, we can multiply that -2 by h minus 2. So here I have the limit as h approaches 0 of 4 over h minus 2 plus 2 bracket h minus 2 over h minus 2 divided by h. And now that we have the same common denominator, we can write it all as one statement here. So here, we'll write it as the limit as h approaches 0, 4 plus 2 h minus 4. So we'll just expand that in the process as well, over h minus 2 over h. Here, we can rewrite it if we multiply that here. So here, we can rewrite it as the limit as h approaches 0, 4 plus 2h minus 4 over h times h minus 2. Here we can see that The 4 and the negative 4 will cancel out, and we'll be left with the limit as h approaches 0 of 2h over h minus 2. Here we see that the h's can cancel out, and so we'll be left with 2 over h minus 2. And if we sub in 0, we get 2 over 0 minus 2, which is equal to negative 1, or that's the slope. And so we're not quite done because we have to find our y-intercept, and we know that y is equal to mx plus b. And here, we know that our slope is negative 1, so y is equal to negative x plus b. And we have a point that we can sub in. We can sub in negative 2 and negative 2. So negative 2 will be equal to negative 2 plus b. Negative 2 is equal to 2 plus b. And negative 4 will be equal to b. And therefore, the equation of the tangent line, at x is equal to negative 2 is y is equal to negative x minus 4.